All right, starting Advent of Code, day one. I'm getting off to kind of a late start here because it's December 7th, but I just was kind of busy last week. I just have a kind of a bare bones implementation here with my repo. I'm doing this all in Kotlin. So if you're just starting off with Kotlin and you want to follow along, it's just at github.com/David Merrick, and then it's under Advent of Code 2020 right here, and I'll provide a link to that in the description for this YouTube video. All right, let's get started. So, I haven't read this yet. After saving Christmas 5 years in a row, you've decided to take a vacation in a nice resort on a tropical island. Surely Christmas will go on without you. Tropical Island has its own currency, and it's entirely cash only. The gold coins used there have a little picture of a starfish. The locals just call them stars. None of the currency exchanges seem to have heard of them, but somehow you'll need to hand 50 of these coins by the time you arrive. So you can pay the deposit for your room. To save your vacation, you need to get all 50 stars by December 20. Oh, this is just kind of an overview of the Advent code itself. But find the two entries that sum to 2020 and then multiply these two numbers together. So if you have this expense report and you have this set of numbers in it, 1721 and 299, then you multiply them together, and so this is the correct answer. Of course, your expense report is much longer. Find the two entries that sum to 2020. What do you get if you multiply them together? Okay. Well, first of all, we will write a test for this. I'm going to go in my day one here. Actually, I'm going to create a new directory here. Resources. And I'm just going to create a file. We're going to call this just going to call this day one. And then I will create a new file here, day1.txt. Just going to add these in here. And then I'm going to create a test class for this. Actually, first I'll make just a regular class in Kotlin for this day one. And then I'm going to create a method called solve. This is not the best naming, but I'll refactor it later. And so this is going to return an int. And it's going to take a expense. It's going to take in a list of ints, which is what our input is here. So I'm going to do reports, and then this is going to be a list of int. And then for now, I'll just add this to do implement. I think there's a way in Kotlin to, is it just to do? There we go. So that'll get rid of those compiler errors there. And then now I'll create a test using JUnit. I'm using JUnit for the test harness for this. Day one test, and then in here, I don't want this to be an internal class. I want it just to be a regular class. And then I'm actually going to rename this just day one, or expense report solver. And then it's already in the package day one. And then I'll rename this expense report solver test. Whoops. And then I'm going to create a test method, test, And then this is going to be fun solve test input. And then we're going to read a file. I can never remember how to do this off the top of my head, so I'm going to go in. I have a previous admin of code that I did for last year that I had all the testing and everything set up, so I'm just going to peek at my own code here. Source test, admin of code, day 1. Here's my test. Okay, so here we go. I think I might have set my stuff up differently last year with my resources. Nope, same way. Okay. So what I'm gonna do here, I'm gonna just have this test get resource as stream, and then it's just gonna be day 1. Is that really what I did? Oh no, I really did set it up as, sorry. So instead of this day 1 living just under this resources, I'm gonna actually nest it in the same class package hierarchy that I have for my test input, so that this java.getResources stream is gonna go directly to that those coordinates of the packages. So I'm gonna change this to IO. GitHub. David Merrick. And then I have AOC 2020. Thought I had it on my clipboard, but just gonna type that. And then day 1. All right, so now we're gonna move this in here. I'm going to delete this directory, and then now I should be able to just read the lines here. Val test input is this, and then I can get rid of this day 1 here because it'll already resolve to this class get resources stream. So what I'm going to do is just make sure that I'm just going to do a quick print ln, or just print this test input, and I'm just going to set a breakpoint. All I want to do is just make sure that my test input is reading successfully. And since this is reading the lines, it should just give me every item on the lines. The one thing is this is going to be a list of string, and I need to map it to an int. So I'll just have to do a map it.toInt here. And I'm going to just start that over. Here we go. So essentially right now I'm doing test-driven development. So I'm setting up my tests, and then I am going to start writing the code. That's right, I have the wrong name for the file. So we need to do day1.txt instead of input.txt. So we run that. We hit the breakpoint. We got an array of 6. 1721 is the first one. 979. Cool, this looks good. All right, I'm going to stop it. And then now I can pass in my stuff here. So I'm going to change this from reports to expenses. This is typically my process of development. You come up with a name initially off the top of your head, and then it changes, whatever. Okay, so now we have this expense report solver test, and then I'm going to create a solver equals expense report solver. Create a new one of this, and then val solution is solver.solve. And then we want to solve our test input. And instead of test input, I'm going to call this expenses, just so it's consistent with that class and that parameter. solve those expenses, and then the solution that we're expecting is this same one that they gave us here, which is 514,000. So then solution should be, I'm using this Kotlin test should be, which is this inline function here. And so we're asserting that this solution should be this. I'm thinking that it would be nice to separate this out into methods that, one method that gives the inputs for this, maybe just as a pair, and then I can test that it got the correct inputs, and I can optimize that function. So I think, but I think I can hide that. I might just have one entry point for this function, but I think internally I'll break that out into these. I kind of anticipate that it will, because there's always a follow-up to these Advent of Code puzzles, and I can anticipate that there's going to be a situation where he's going to ask us to find two entries that sum up to some other number and then multiply those together. So I think what I'll do is I think I'll have this solve and then pass in a goal sum, and I'll have that be an int, and then in this case I'll pass in 2020 for that goal sum. Okay, so now we can implement this method. I'm just going to start off kind of with a brute force solution and then optimize from there. So I think the first thing that we could do is just take these expenses, we'll take them as a sequence, and then just multiply or add them together with every other thing in the sequence. Or take the list, take for each item in the list, add it to every item in the list minus that item, one by one, and then if you find the one that's that goal, then you're done. I wonder if there's a way to do this using the functional idioms in Kotlin. I think for now I'll just do, I'm just going to brute force it. I'm just going to do a for loop. There's got to be a cleaner way. For loop in Kotlin. Kotlin for loop. Okay, so call it for for I and expenses, and then I'm going to change this to a set so that I can filter it out on the second, because you don't want, what we don't want is for some kind of false positive where you had like 1010 and you added it to itself on accident and then you ended up with 2020, but that's not actually something that's in the set. You don't want to add duplicate numbers together. So I'm going to convert this to a set. I'm going to say val expense set equals expenses dot to set, and then for I and expenses, this is actually, yeah, for I and expenses, and then for, we'll do a second for loop here. This is extremely inefficient, by the way. This is just the brute force implementation. We want to do J in expenses dot, we want to remove I because we're looking, I is the number that we want to add another number to. I'm explaining this horribly, but does set have a remove function? I'm going to look at the docs for set. Set has remove, so, but I don't know, this is probably an immutable set. So what we need to do is create a new set. Val I set. God. This is so hard on when you're, I've never coded on video before, and it's like when someone's watching you, you just have a hard time thinking. So I really need to do expense set dot to mutable set, and then I can do a remove. So first I need to convert this to val test set equals this, because I'm testing to see if I adds to any number in this set to make this goal number. So I'm going to convert that to a mutable set, and then I can do test set dot remove I. The thing is, this doesn't actually work because a set contains only unique elements, and there's no guarantee that these are unique either. So you could have two expenses that add up to 2020 that are the same number. So this actually brute force solution is not going to work. We need to keep it as a list, but we need to exclude that index of the list. So I need to keep track of the index that I'm at. I'm going to scrap this. Kotlin for loop, I just need to have this index in the loop. So I think I can just do expenses.indices, and then I is going to represent the index, and then let's say A and B are our test numbers that we're going to sum together. So let A equal expenses, and then I for that index. I'm writing. This is such a train wreck right now. Let is not a Kotlin thing. I'm writing JavaScript here. I'm so embarrassed right now. Okay, so I got this A value at the expenses at that index, and then what I need to do is expenses.toMutable list, so that I can modify it, because Kotlin by default has immutable lists. So I want to do val test list equals this. It's going to create a copy that's mutable, and then test list dot remove at, and then I want to pass in I for that index. And then now we have a list of everything in the expenses that does not contain A. Okay. There's got to be a better, what is the word for I'm going to call this input A because it's going to be the input to my sum, right? I just don't like input A is not a great name, but A is even worse. So I'm going to go input A is this, and input B is going to be this test list. I'm going to go for J in test list, and then I'm going to add input A plus J, and then I'm going to test that. If input A plus J is equal to goal sum, then we need to break. And we need to break at this outer loop. This will only break here. What I'm going to do is I'm going to do a private function that will give me these inputs to add together, and then I'll return them as a pair. So I'm going to call this private get inputs, and then this is going to be, it'll have the same parameters as this one, but this is only going to return the inputs, and this is just to start to break this out into functions and make it easier to reason about. So I'm going to move this here, and then this is going to just return a pair of ints. Why is that complaining? I'm going to change this back to to-do. No, it's the Kotlin function, to-do, and there we go. Get inputs. I don't know why this is complaining right now, expecting member declaration. Oh, it's fun. There we go. Can't type. All right, it's going to be a pair of int, and then pair of int. There we go. So if these equal the goal sum, we want to return a new pair of input A and J. And then here, what we want to do is val inputs equals get inputs, and then we're just going to pass those expenses here, and then the goal sum, and then we're going to in this requirements it said you need to multiply these together, and so we're going to take return inputs dot first times input dot second. I still don't really like this input A. What is the word for? I'm going to call it operand A. And then I'm going to call this one operand B, because there's some confusion here. Like I here represents this index, but J actually represents the number value in the expenses. So I'm going to call this operand B. And then there's a case that we're not handling here where, let's say that nothing was found here and it never returns. So I'm just going to throw a runtime exception and say operands adding up to goal sum not found. So then this compiler stops complaining. So now this should work. Solver.solve. If it doesn't work, it will throw a runtime exception. But what I'm going to do is have a breakpoint here just to confirm that the solution is the one that we're expecting. And here we go. We got this solution of 514579, so this test will pass. All right, let's see if we can come up with a way to optimize this further. I don't like these for loops. This is a O of n squared solution because we're essentially taking everything here and then we're iterating and finding everything that adds up to this goal. I think one thing I can think of off the top of my head is that we want to filter out everything that's greater than this goal sum. We can automatically filter out. So I'm going to just say val inputs or val expenses is filtered expenses is expenses dot filter, and then we want to filter anything that it is less than or equal to goal sum. I don't know if it's valid to have an expense of 0 here. I guess we can't rule it out. You're not going to have a negative expense, I don't think. So here's all our input. So it is less than or equal to goal sum. We can safely do that. And then we'll pass in these filtered expenses. That's really just kind of it's kind of a surface level optimization. What I would really like to do is if there's something here that that I could do to speed this up. What I notice here is that this is one of the smallest numbers. 299 is one of the smallest in this list. 1721 is the largest. And so I wonder if we could sort this list and then kind of work our way in. If that would maybe be a faster way to optimize this. Maybe some kind of a binary search. I'm also going to, yeah. I do want to see if this works on the bigger this bigger set here, just to make sure that this still works and that there's not some kind of edge case that we're going to run into with this. So I'm going to get my puzzle input here, and then I'm going to copy this. I'm going to call this day1 full.txt. And then I'll factor this into a private fun just to get these so that we're only doing this once to get these inputs that we're testing. We want to do private fun get inputs. And then I'm going to pass in a file name, which is a string. We're going to read this file name. And then this is going to return a list of int. So val expenses is, we're going to take inputs, solver, yeah, so the rest of this is going to be the same. And then usually I kind of like doing this in my test because these functions are, I like just having them. And Kotlin allows you to have spaces in methods like this. I don't like doing this in production code, but I do like doing it in test code. I feel like it makes it a little more readable. So now I'm going to do solve full input, and then we're going to do full day1 dash full.txt. We're not going to make any assertions about what the solution should be, but I am going to print ln this solution. And let's see what it is. $121,396. Let's see if that is correct. And that is indeed correct. And I'm just going to take a peek at what part 2 is. The elves in accounting are thankful for your help. One of them offers you a starfish coin. They offer you a second one if you can find 3 numbers in your expense report that use the same criteria. So this is even more, this is like an O of n cubed essentially, because you have to, if you're using my solution, you'd have to iterate 3 times over the list, and so that's pretty inefficient. ultimately you do have to test. I mean, there's no way to know ahead of time unless you did some kind of mathematical trick. Like, the worst case, I think, is you're always going to be iterating over this 3 times. I'm trying to think of yeah, so with this one it really was like the lowest and the highest number. And in this case, these ones were, they kind of skewed more towards the middle. I don't know, I can't think of anything off the top of my head, and I don't want to use up too much more time in this video. If I do think of something, I'll make a second video and do it separately. I think with this one, I'll do, I'm just going to do a brute force solution and maybe make this recursive. Because I noticed that we're doing this via a few different loops, and so I wonder if I can I'm going to make this expense report solver part 2. Duplicate this first. Just going to create a separate class for this, and then I'm going to make this a part 2 test. I think I'll just write this as 3 loops first, and I'll think of a way to optimize it. So for ion expenses.indices, and then we want to do, then we're going to have 3 operands here. We're going to have this A, B, and C. So in this case, we want to do it like, so I think the very first thing I'm going to do is at least get a, I'm going to make a method that creates a new list without that thing at that index. And then I'm going to say current index is an int, and then expenses is a list of int, and then this is going to return a list of int. So what this will do is convert expenses. So I'm going to return, actually val new list is expenses.toMutableList. So I'm essentially going to do the same thing up here. I'm going to create a mutable list out of this, and I'm going to rename this method so it's a little more general. So I'm going to say with index removed, and then input list is going to be this list, and then remove at this index here. Inputs.toMutableList, and then return, well, new list dot remove at, and then return this new list. There we go. I don't know if there's a way to, I'm just going to check to see if there's a way to do this with, I guess in Kotlin there's a method called copy, but that's with data classes, right? I think you can copy an object, but it's only for a data class. So I couldn't just do this inline, or I think I have to set this to a variable. Create a mutable list, remove this. I don't know that there's like a shortcut to do this. Yeah, I don't know. Not a big deal. So this will generate this list with this index removed. So I'm going to say this test list is, now I don't need this line. I can just get rid of this. And then I'm going to say expenses, or with, I'm going to say with index removed. And then I'm going to pass in this expenses and then the index of I. And now instead of operand B, I'm going to call it, I'm going to do the same thing here. I'm going to say J. J is in here. And then it's going to be dot indices. And then I'm going to say val operand B is equal to, I do need to, save this as to a variable so that operand B can be at that index. This is super ugly, I realize. I'm just going to call this val. This is some of the worst code I've ever written. I'm embarrassed to share this with the world. This is the first time I've coded on video, so whatever. This is going to be super sloppy, but here we go. This is going to be J expenses. It's just going to be an array or a list that's just going to get us this far to be able to get this operand B. I'm going to call this, so this is going to be with index removed here, and then we can call J expenses dot indices, and then that will give us the index, and then operand B is going to be J expenses, and then it's at this index of J, or no, J expenses J, and then the other thing we're going to do is we're going to do this thing over again. We have to do another nested loop, which is going to be K expenses, and then so we're going to do with index removed J expenses, and then we're going to remove index J, and this is going to be for K in K expenses dot indices, and then operand C is going to be K expenses of K. Are you lost yet? Because it's super messy. There's got to be a cleaner way to do this. But for now, we're going to do the same test. So if operand A plus operand B plus operand C, and we need to just order of operations here. Put these in parentheses, equals to the goal sum. Then we return, and now it doesn't work to return a pair, so we're going to do I'm just going to say that this is just a list of int. And then we'll just take the product of this this list here. Or we could do I think we could do a reduce on it. So we're going to return a list of operand A, operand B, and operand C here. So now what we can do is inputs dot reduce. Can we do the product? No. I think we just need to do a reduce. And then I think we can do A, B. Would that work? Yeah, I think that's fine. So A and B, and then the operation is going to be A times B. I do want to I want to test that real quick because I don't use this reduce operation too much with Kotlin. I think the way it works is it accumulates a value starting with the first element and applies the operation from left to right to the current accumulator. So I do want to just double check that this is going to behave as I expect it to. I'm going to create another folder real quick for part 2. But for now, I just want to test this reduction function. So I'm going to say val inputs is equal to a list of, say, 1, 2, and 3. We know that 1 times 2 is 2, times 3 is 6, so we're expecting this to be 6 inputs. And then I'm going to just dot reduce in the same way. And then I think this should return type S, which is going to be whatever this value is. So that's okay. So val solution is this, and then solution should be 6 is what we're expecting. So let's try that. Okay, so that works as expected. So now we have this. This does look like something that we could do as a recursive solution. So I'm kind of thinking of a method that maybe takes the accumulated sum so far. The thing is, it would have to be aware of how many levels deep that it's gone. So in this case, we would want it to go 3 levels deep, right? So it would need the recursive function would need to know what level it's at, right? And then you would also need to pass in the current list, and then you would also need to pass in the goal sum. And so once it reaches the base case, then it could test these operands. It's still ultimately not any more efficient. You're still going to have a solution that's O of n cubed, but it would be cleaner than reading this garbage here. This is kind of a rat's nest of nested loops, which I don't like looking at these. These are really hard to read, and then you could have fewer variables. So I think what I'm going to do for now is I'm going to test this solution to make sure it's correct. First of all, I can use this day1.txt. I can actually just use that as the input. Oh, okay. So the input hasn't changed. So I can just delete this part 2 here. So what I'm going to do is I'm just going to make sure that this example input lines up with what they said that this should be. So I'm going to go here and do expense report part 2 solution test. I'm essentially going to do the same thing here. I'm going to get these expenses. I'm going to create a expense report part 2 solver. I want this to be expense report part 2 solver. And then the solver.solve, and then this should be this number. Or no, not this number. Multiplying them together is this. So the solution should be this number here. Now, my coworker did mention that you might need a long for one of these, and I want to make sure that this doesn't overflow the max of integer, which I think is 32 bits. And so it's 2 to the 31st minus 1. One of the syntactical things you can do in Kotlin is this. So this actually should this is fine. This will be okay. We don't need to make use of longs for this. So I'm going to do this test input. It worked. So now I'm going to solve my part 2 input. So I want my day1 dash full.txt, solve full input, and then I don't know what the solution should be, but I am going to print ln the solution. Here we go. And then it spit out this value here. So I just want to do a quick sanity check. This is 64. It is odd that, oh, I guess it's a little strange that this is, does that make sense that this is less than this one? I think it does, because you're multiplying together 3 smaller numbers rather than 2 bigger numbers that are going to add up to 2020. So I think that just makes sense from a smell check. I'm going to submit. I got the right answer. Okay, so day 1 is done with the brute force solution. I'm going to take a few minutes and just see if I can come up with a cleaner way to solve this. I'm going to go ahead and commit this code. And I appreciate you bearing with me. I think this will be, I'm going to try to do a recording for each day of Advent of Code, and I'm hoping that I'm going to get better at this. It's a whole different thing. Like, I'm so used to writing code and not being on video, and so this whole thing where I'm narrating what I'm doing as I'm coming up with the solution is a whole different way of using my brain that I'm not used to. And so it's kind of awkward, kind of janky, but we got through it. And if you're still here, I appreciate it. So I'm going to commit this real quick. Day 1 solution. I do like that GitHub finally switched over the default branch to be main. That's a new thing. Okay, so it's still, my idea of recursion is still going to be not the most efficient solution that you could come up with, but I can't think of anything better to do without going and doing some kind of a deep dive into the math and deciding, if there's some kind of optimization where you could sort the list and start at the highest number and then add it to the lowest, and then maybe work your way into the list. You could probably shave off a lot of time doing that. What I am going to do is just make this syntactically more pleasing to read. And to do that, I think I need to create a recursive function that will, it's going to be a private function, and then it's going to return ultimately it's going to return this list of operands. I'm going to say I'm going to call this recursive get inputs, and then it does need to take in the expenses, and then it still needs to take in the goal sum, and then it needs to take in a level. So this is sort of breaking the rule of clean code, where you don't want to have too many parameters for a method. What I could do is just have this solver. One thing I could do to reduce a parameter here is to have this goal sum be a property of the solver itself. So I can make this a private val goal sum, and then that's the int there. And then I don't have to take this in as a parameter on the method. So that reduces that by 1 parameter. And what I can do is I can take my operands. My operands so far could be a list of int, and then obviously, so I'm going to put these on separate lines just to be cleaner. And I'm going to make this full screen because this is just an optimization of, we already solved the day 1. So we're going to take in the operands that we have so far, and then we want to take in the level, which is an int. So that's the current level that we're at. So initially when you call this method, it's going to be, and we can default this to 0. And then this is going to return that list of operands. just like this one. Same method contract here. So it's going to return a list of int. And then what we want to do, the other thing we need to keep track of is what's our goal level. Which that could be another property of, actually this could be the num operands that we want. So this could be private val num operands, and then that's an int. Okay. Perfect. Okay, so then we can remove this. We need to know. Actually, we don't need to know that because we can use the count of the operands here to determine what level we're at. So we can actually we can reduce that even more. So we just need the expenses and the operands, and then that's going to return a list of the operands. Okay, cool. So we're essentially going to do the same thing. We're going to go actually, we need one more thing. We need to know what the current operand is. Right? We have to have some way of knowing where we're at right now. So let's just imagine that we're going to call this method from here. So we have, let's just start off with this initial operand. And then I'm going to work my way up from here. So usually with a recursive function, my approach is to just take the base case. So if my number of operands dot size is equal to the num operands, then I want to evaluate whether they add up to the goal sum. The thing is, we don't know off the top of our heads if this is, I mean, it almost feels like it needs some kind of a Boolean to know if it's true. I almost wonder if it would just be better to generate a, instead of doing this recursively, generate a list of all possible combinations of inputs. Let me think about this for a minute. If this recursive get inputs. I'm still trying to think if there's a way to do this recursively. A plus B plus C is the goal sum. Let's say this function's calling itself. I wonder if this should just return a single int instead of a list of ints. Does that make sense? Although it could just return a list of a single int. So if operands dot size is the number of operands, then this is the base case, right? So then we want to check if operands.sum is equal to the goal sum. So maybe the emptiness of this list is a property that we can use to key off of whether it's the correct solution or not. So recursive get inputs. So we can return, in this case, we'll return the operands. Okay, so this is our base case. We have a number of operands equal to the goal operands that we want. And then otherwise, we want to do recursive get inputs and then expenses, but we still don't know the index that we're currently at. Super frustrating. So we do need to pass in the index. So current index is an int. Recursive get index with index removed. And then we want the expenses and then remove at current index. And then we're going to test with an operand of with the currents with an operand dot to mutable list dot add expenses dot current index. Recursive get inputs, and then I don't know if this is going to work, but it almost seems messier than the other way. With the index removed, current index. We still need to keep track of our place in this list. The problem is, this is just adding them up. I don't like this. I don't like this recursive approach. But I do like this idea of having the goal sum be this property on the expense report solver. So at least I'm going to have that optimization for now, and then I can remove this, the need for this extra parameter here. So then in my test, I'll just add expense report part 2 solver. 2020 goes here, and then it goes here. There's got to be a general purpose approach to this, though, with oh, I see. Okay, this goal sum value doesn't need to be here, and then we'll go back and yeah, it does seem like there's got to be some kind of general purpose solution where you can pass in the number of operands that you want, and then this inputs will give you that list matching that number, whether that's creating a combination of every possible combo. I mean, it'd be pretty easy, like using the Kotlin functional idioms, to just take that list and then take a list of lists. So it'd be a list of all the possible combinations of 3 things in these 3 integers in this expense report, and then go through and find anything in there where the sum adds up to this goal sum. I wonder if there's a way to do that real quick. Kotlin combinatorics. So this will give us some permutations here. 3, 2, 1, 1, 2, 3. Permutations of 3. You'd almost want some kind of factorial approach, though, you know, because these are just reorderings of the same items. It'd be nice to have the order not matter. Yeah, so that we actually want a combination, really. 1, 2, 3 combinations 3. Yeah, so this could work. Why don't we pull in this library and then use this combinatorics KT just to clean this up a little bit. I'm going to pull in implementation combinatorics. So let's take this list. I think I'm going to forget about this. It's it's kind of a small optimization, but whatever. Get inputs, and then we want expenses, and then how did this work? So we want combinations of 3. So we want to take this, and this will give us a list of all possible combinations of these expenses. So expenses dot combinations of 3, and I assume we just need to. List of ints. We'll just do a Gradle refresh to pull in that library. So this I assume that this is just some kind of extension function on here, so this should work, right? Here we go. Okay, so I can do combinations of 3, and then what we can do is just map these. Actually, we can even do any, and then we can just do a reduction here. It dot sum, or we could just even do sum. It dot sum is equal to goal sum. And that gives us a predicate on the list. So really, this will return. I'm going to do first instead. So first, and then this will give us the list of ints. Cool. And I think that this throws an exception if, yeah, no such element exception. Okay, so this is much cleaner, just generate a combination. And this is effectively what we were doing before too. So I'm going to do return. This gives us a list of int. And then let's run our tests to just to see if it still solves that test input the same way. And then we can even optimize this further and just have a private val of a num operands, and then that's an int, and then we can have this be num operands, and then when we're instantiating this, we can create a, let's say num operands is 3. I'm going to put a const val here, num operands equals 3, and then this is going to be goal sum is 2020. Goal sum, and then we want the num operands here. And then let's just, what did we say for our solution? I think solution, let's try this out on the bigger one. I think this was the solution here. Should be this, and I like to separate these large numbers with these underscores here. So let's just run all those tests, make sure that everything's kosher here. Okay, cool. Yeah, that's a lot cleaner just to generate those combinatorics. I like that that functional approach here. Then we don't need this index removed function. And you know, this solution will work for the first and the second parts of this, because with the first part we were doing it with a number of operands of 2, and now it's flexible. We can pass in whatever number of operands we want and pass in a goal sum. So I like this. This is a lot cleaner and easier to read. So I'm going to commit that. Thanks again for watching. I may or may not edit out all of the thinking and the back and forth, but I appreciate you watching if you took the time, and stay tuned. I'm sure I'll get smoother at this, and I appreciate it. So thanks again. Bye.